Hello friends, how are you? I hope you all are well. This video just extension of my previous video where I explained regarding electric potential and potential energy. Today's topic is potential due to an electric dipole. Potential due to an electric dipole. That means if a dipole is there surrounding that, the electric field is there. In that electric field, how to calculate the potential? So you know that dipole is two equal and opposite charges separated by a finite distance. The distance, this is the distance between negative charge and positive charge. This is the distance. Okay. So, two equal and opposite charges separated by a finite distance. That one I said the dipole in the previous video I have explained already. But here the fact is that we have to find out the potential at any point surrounding it. For example, at this point I want to calculate the potential. Clear? So, in this case, the distance between this point and the dipole, then which one will take the distance? Is it distance? Is it distance? That means we will take the midpoint of the dipole. Suppose this is the midpoint of the dipole. This distance, let this distance is equal to r. The distance is r. Now, due to this negative charge, there will be a potential at this point. For example, this point name I am giving P. The potential due to this point, this negative charge is V1. Similarly, there will be potential due to this positive charge. That means V2. Means I can say that the total potential will be V1 plus V2 due to the negative charge. This charge, negative charge minus Q. This is the positive charge I have taken. Equal charges, both I have taken. Here I have taken minus Q. Here I have taken plus Q. Now, suppose this distance making an angle with this dipole is theta. Okay. Now, I have to calculate the potential at this point P in terms of r, and also suppose the distance, dipole distance I have taken 2a, or you can say here to here is the a and here to here also it is equal to a. So I have to express this potential in terms of r and theta. Okay. Now let us join this point. Okay. For example, this distance I am taking x, it is an intermediate distance. Okay. Similarly, here to here, suppose this distance is equal to y. Clear? This is the intermediate distance, but I have to express the dipole in terms of a and theta. A is the half of the dipole distance. Here the dipole I have taken 2a, the dipole distance between the negative charge and positive charge. But this distance a is very small in comparison with the distance r. So I can say that this EA is very smaller than R, because we find dipole in a molecule. You think how much the small distance. There is no doubt that these two equal and opposite charges are separated by a finite distance. Now let us see. So the potential at the point P will be the sum of V1 means potential due to the negative charge Q and potential due to the positive charge Q. So I can say that this V is equal to V1 plus V2, or I can write this is 1 upon 4 pi epsilon naught into 1 by distance here to here I have taken x. Clear? Plus, oh sorry, I have taken the charge is minus q, so definitely I shall write here minus q. Okay? So next one, V2, that is also equal to 1 upon 4 pi epsilon naught plus q. The potential due to the plus q, here the potential due to the minus q. So the distance, arbitrary distance I have taken here, the intermediate distance y. So I can write this is 1 upon 4 pi epsilon naught q, I am taking common here, minus 1 by x plus 1 by y, or I can write 1 by y minus 1 by x. Listen carefully. So the fact is that I have to use the term r and a, not y and x. Let us see. Suppose I am extending this distance. Okay. Now this point I have given P. Suppose this point you give the A O. From here you draw one perpendicular. Suppose this is equal to M. Clear? Now from this point also you draw one more perpendicular here. Okay? Suppose you give its name as M. Okay? Now listen carefully. In these two triangles, you will find that here to here is A, here to here is also A. Clear? These two angles are vertically opposite angles, and I have drawn here to here the perpendicular. This is 90 degree, this is also 90 degree. That means you can say these two triangles are congruent. Now let us see. In this case, I want to take cosine theta in this triangle, or I can say that, let us say here cos theta. So you know that cos theta is adjacent side by hypotenuse. So in this triangle, adjacent side is the OM. So I can say that OM upon hypotenuse means I have taken A, implies that OM is equal to A cos theta. Similarly, in this triangle, I can say that ON here to here, ON. How I find that ON is equal to A cos theta? ON also I can find A cos theta. Now let us see. In this case, the distance PM almost equal to PO. How? Now I said that this A is very small. You think that the distance is here to here. That means if I draw this line, it will be here. So in this case, if I draw the perpendicular, that means the PM will be almost equal to PM, which is equal to PO plus OM. it will be almost equal to x. That means x is equal to Pm. Why x is equal to Pm? I said that this A is very small. That means this one will come near to here. So if I draw the perpendicular, that means the Pm and this x almost will be equal. Okay? So it is almost will be equal. So I can write in place of Pm, I can write this is Po plus Om. Po plus Om. So Po, I have taken the distance from the point P to the midpoint of the dipole as r. So I can write this is r plus Om. Om we got A cos theta. So this is A cos theta. Similarly, I can say that y is equal to, now listen carefully, I said that the distance A very small in comparison with the r. That means y almost will be equal to Pn, which one I can write Po minus On, because I want to express in terms of r and theta, I want to avoid x and y. So in place of Po, I am writing r minus On, which is equal to A cos theta. A cos theta. Now let us see here. Now the V is equal to V1 plus V2. I got 1 upon 4 pi epsilon naught q into 1 by y minus 1 by x. So I can say that this V is equal to 1 upon 4 pi epsilon naught q into 1 by y. That means 1 upon r minus A cos theta minus 1 upon r plus A cos theta. See here. So I can say that this is 1 upon 4 pi epsilon naught q. This is the LCM I have taken, r square minus A square cos square theta. Here r plus A cos theta minus r plus A cos theta. Okay, so in this case plus r minus r cancel, and this A square cos square theta, it is subtracted from r square. Listen carefully, here A is very small, so whenever I am subtracting very small things, I can neglect this term. I can neglect the term A square cos square theta. It can be neglected. It can be neglected. It can be neglected. If I can neglect this, I am writing here, I think there it is appearing or not, I don't know. Okay, see here. So I can say that this V is equal to 1 upon 4 pi epsilon naught q. Here A cos theta plus A cos theta, that is 2A cos theta divided by r square, because A square cos theta neglected. Listen carefully. Here A cos theta, here also A cos theta. Here in case of the multiplication and division, I am not neglecting. I cannot neglect there, but here I am subtracting. That's why it can be neglected. So I can write this is 1 upon 4 pi epsilon naught. In place of q into 2, I can write p cos theta upon r square. What is p? This p is equal to q into 2a, which is the dipole moment. So we know that dipole moment is the product of charge and length of the dipole. So this P is dipole moment. Clear? Now let us see. So we got that the potential is P cos theta divided by 4 pi epsilon naught r square. I can express this in vector form also. How? You see that in place of a P cos theta, suppose I am writing vector P into unit vector r. Listen carefully. I have written the vector P and the unit vector r, means I have taken the direction of the position vector. Let us see. So in this case, in dot product, what we do? We do the product, their product. So here the unit vector I have written, means its magnitude is 1. That means P into 1. Okay. P into 1 into cos theta. Cos theta. That means P cos theta. So I can write in vector form 1 upon 4 pi epsilon naught. This is the vector P into unit vector. Okay. So divided by r square. We can also write like this. Otherwise here also I can keep the cap. Here also I can put the r mark. That is also possible. So one more thing, listen carefully. In this case, the theta is in the first quadrant. The angle may be in the first quadrant, maybe in the second quadrant, maybe in the third quadrant, maybe in the fourth quadrant. Already you know that if it is the first quadrant, then its cos value will be plus. This is the plus, this is the minus, this is the minus, this is the plus. Now, suppose in this case, this is the in this axis, okay. Here the I have written 0. Clear? That means if the theta equal to 0, if the theta equal to 0, that means cos 0 equal to 1. I can write there 1 by 4 pi epsilon naught P by r square. Clear? If the theta is equal to 180 degree, see here, in this case, in this side, the value of V will be maximum. This is the positive. And here maximum negative, or you can say it is the minimum value. So if it is 180 degree, if it is 180 degree, so definitely this value will be negative. Clear? Because in this case cos 0 degree equal to 1. We know that cos 0 degree is equal to 1. Cos 90 degree equal to 0. 180 degree equal to minus 1. Okay. So again it came to the 0. That means the value of the potential in this equatorial plane all time is equal to 0. And this value of this potential in this side will be maximum, which is a positive. And if it is 180 degree, then it will be equal to minus 1 upon 4 pi epsilon naught P by r square. Because cos theta in this case will be cos 80 degree, which will be equal to minus 1. So I can say that this V may be plus minus P upon 4 pi epsilon naught r square. So this is the fact I discussed about the potential due to an electric dipole. So we found that this is P cos theta divided by 4 pi epsilon naught r square, and in vector form I can write like this manner. Okay, and if you consider this side where the theta equal to 0 degree, then I can say that potential. If theta is 180 degree, that means this is the maximum value, this side this is the maximum negative value, that means minimum value, which can be written as minus 1 upon 4 pi epsilon naught P by R square. So this is the fact about the potential dipole. I hope that you might have understood this video. So until the next video, bye.